then
Okay.
it should be closer to 50.
Okay,
So, yeah.
let's see. Okay, let's see. I'm going to share my screen and I'll try to explain you what I meant in this situation. For example, here we do have a clear-cut situation because if you do see that equiphasic lead, yes, we do have an equiphasic lead, such as lead number 1. Okay, so we have to have a perpendicular, so the axis is located perpendicular to lead number 1. Lead number 1 is located at 0, so the perpendicular is plus 90 and minus 90. We have to look at, let's say, AVF. If AVF is positive, it's located at 90. That's a clear cut. It's not in the opposite. If you had negativity in AVF, of course, you had minus 90. That's a clear cut. It's nothing to worry about it because this is not the case what I meant. Okay, let's look at, for example, here. Now, if you look through lead number 1, 2, 3, or AVR, AVL, AVF, none of them is equiphasic, yes? So we cannot go for the equiphasic lead, or we could, but what we said, let's go for the smallest deflection, and I would choose, let's see, the smallest deflection is lead number 3, okay? All right, so we have to be perpendicular to lead number 3. Lead number 3 is located 120. So you have to count back 90. It's meaning that you do have 30 or you do have 210. Okay, now we go for, let's see, you can go for AVR because that's 210. Whether it's positive or negative, that's negative. So this around 30. However, lead number 3 is still positive. It's meaning this is more than 30. Now you can add, for example, 10 degrees. You can say that at 40 or 50, doesn't matter. 40, 45, the axis is, so it's okay. All right, it's understandable because it's still positive lead number 3.
I think so.
I think so, but you are not sure. Yes?
Yes.
Okay, I will do a different one, a different approach. I will turn on the paint, okay? Turn on the paint, and I'm sharing the paint on my picture, and I will show it to you, okay? Good. Okay, so this is the, let's see the table. All right, now let's draw the hexaaxial system. I try to draw it. Okay, this is lead number 1. Okay, that means this is 0. All right. Okay, 0 degrees. This is lead number 1. AVF, this is goes to 90. Okay. Lead number 2 is goes 60. Lead number 3 goes 120. Okay. So this looks like 60 degrees, and this is 90 degrees. So 0, maybe I can write here. It's much easier to write. So that's 60. That means 90. I mean, that means 90. That means 120. Okay, that's 120. Okay, now, so what do you want to see? Lead number 1, that was lead number 3, I'm sorry. Lead number 3 was equiphasic. It's meaning that the main electric axis is perpendicular to lead number 3, so it's perpendicular to 120. Okay, which is perpendicular to 120. If you subtract, I'm drawing this one. If you subtract 90 degrees, okay, so go back 90 degrees here. Okay, that's all right, 90 degrees. Or you add 90 degrees to here. These two areas exactly perpendicular to lead number 3. That was 1, it was 210, and that was 30. Yes? So far it's clear?
Yes.
Okay, now let's see which one that we deal with. We deal with 210 or we deal with 30. What we have to look at, we have to look at AVR because AVR is exactly 210. Or you can look at lead number 2 or 1 because if they are positive, you are here. If they are negative, you are here. But look at AVR. When we looked at EVR, it was negative. This is why I said we do have an axis that is close to 30. However, lead number 1 was trial positive. What does it mean? It meaning that the axis is less than 90 degrees to lead number 3. Okay, because this area is positive, this area is negative for lead number 3. So this is why I said, okay, let's add another 10 degrees, for example, to lead number 3 because it's still positive. And let's say now we have about an axis around 40 to 50 degrees. Okay.
Yeah, I understand now. Thank you.
Okay, you're welcome. All right. But we can go for a quadrant approach if you wish. That's another possibility. If you go for a quadrant approach, let's look at this one. First of all, look at lead number 1, lead AVR, both positive, normal. You can say immediately that's normal. And maybe nobody asking you the exact axis, but if you want to narrow down the axis, I say, look at 1, 2, and 3, and choose the biggest one. The biggest one is lead number 2, yes? So it's meaning, maybe I'm sharing my old desktop. Okay, so it's meaning that we are parallel with lead number 2. Okay, so okay, so we are parallel with lead number 2. Okay, it meaning that the axis should be around 60 degrees. Okay, so let's go. So this is mostly parallel with lead number 2. Okay, however, if you had an axis that exactly 60 is equally placed from lead number 1 and lead number 3. So the reflection of these two leads should be equal. So when you look at the QRS complexes, it should be equal in lead number 1 and in lead number 3. However, lead number 1 is bigger one, meaning that the axis is closer to lead number 1. So this is why go around 10 degrees or 50 degrees, and you are here again. Okay.
Okay.
But don't worry, this axis be the smallest problem. Anybody else has any question? Okay, so the axis, okay, yes. You can say it.
Yeah, I have a question about the axis as well.
Okay.
Is it possible to, for example, you do an equiphasic approach and the quadrant approach, is it possible to have like contradicting results?
Well, you don't need to contradict your results. Basically, in a true life, the axis is located on the papers because the instrument is writing the axis immediately. So you don't need to deal with. This is good for, let's see, for practicing only at the beginning. But in a true life, there is no way. And nobody wants to, let's see, fail you because you could not determine the axis in the right way. There's no way. It doesn't matter the axis. If the axis is a normal range, it's normal. If it's in a pathological range, yes, we do have another diagnosis that we have to make. That's it. So you don't need to be so precise on and have a, let's see, evaluation based on equiphasic one, and let's prove it by using the quadrant approach. But usually they both will show you the same results. So there's no way that these two, let's see, testing give you different results. I don't think so.
Okay, thank you.
Anybody? Okay, if not, let's see the homework that you did. Okay, I'm going to share my screen. I think that should be good. And after, let's see, I have to find the homework that you had. Okay. Okay. All right. So the first one, 101. Okay. Who is going to present 101? You can share your screen if you wish, or you can use my screen. Which one that you want to choose?
Your screen is better, I think.
Okay. All right. Now let's see. So the first presenter should be Rania. Is here? Not? Okay. Maximilian, are you here? Nobody's here? Okay, let's look at. No? Okay. None of them is here. Okay, so who is going to solve this problem?
I can start.
Okay, all right. Now tell me your story. I give you the remote control of my cursor. What was your name, please? Vivian?
Liel.
Lian. Lian.
Liel. Yerushalmi.
Liel, it's right here. Okay. Now you can have a left click and after you can control my mouse. Yes, it does work. Okay. Let's see. Let's go to 101. Okay, let's start with 101. Okay, good. First of all, rhythmicity. We cannot hear you. Uh-oh, what happened?
I'm not sure, but can I tell you like the one I did? So it will be for sure because it's recent for me.
Okay, I will tell you right now. Okay, that's be the best one. So let's go to every list that or every ECG tracing that we had. Okay, I remove, let's see. Okay, first of all.
Professor,
Yes?
can I do this one?
Yes, Vivian. Okay. Do you want to have the cursor?
No, it's okay. I think.
Okay, now tell me.
I think the heart rate is about 66.
Rhythmicity first. Rhythmic or not?
1 second, I just open it.
You can look at my
I think it
screen.
is
Yes,
because
it's rhythmic. Okay, next one, you can calculate the heart rate. Let's see the heart rate.
so I counted the number of big boxes and I said it's approximately 4.5 between the
Okay,
QRS
4.5. So what does it mean?
Then I divide 300 by 4.5, so it's about 66.
Okay, that's good. Or 70, doesn't matter. You can say the both. Okay.
And then so
axis.
I'm doing it while I'm looking. So if I use the quadrant approach, then
Yes.
one is positive and AVF is also positive. So it's normal axis, I think.
Exactly, normal axis. Now, which is the equiphasic one? You can see that lead number 3 is almost equiphasic, sometimes positive, sometimes negative. So it's about 0. So again, it has to be around 30 because this fits to the 30 because we are on the left side and lead number 1 and lead number 2 about the same. So this axis is located exactly in the middle of lead number 1 and AVF. I mean, lead number 2, lead number 1 and lead number 3. Okay.
Okay, yeah.
All right. Now, another one, we have to go a little bit further because today we're discussing the impulse formation abnormalities as well. So the next one that you have to check whether is there any P located in front of the QRSs?
Sorry, can you repeat that?
Okay, today we are dealing with the impasse formation abnormalities as well. So we have to look at where the impasse is formed. Do we have P wave in front of the
Yes.
QRS? Yes, we do. And this P is exactly coming rhythmically and the shape about the same. So that could positive in lead number 2 and negative in AVR. So it can be a sinus rhythm. Okay, so everything is fits into the normal sinus rhythm. Yes? So that's be your diagnosis, a normal sinus rhythm. Okay, let's go 102. Who is going to solve this 102? Anybody can do it because the presenter is not here.
So first we're saying that it's rhythmic because
Okay.
it looks like they are the same. Then the rhythm, like the beats per minute will be like 75 because you're dividing it by 4.
Well, no, it's not. I don't think that is 4 because 1, 2, 3. Yes, it's 4. It's 75. Okay, 75. Okay, good. Go 75. All right. So it's normal rate. Okay.
Yeah, and then the axis, lead one is like epiphasic, so we can say it's positive.
Okay.
And
Equiphasic. Okay.
equiphasic, and the AVF is positive, so it will be in the normal axis.
Yes, and should be the axis, so you can say precisely what the axis is.
What do you mean, like the?
Well, exactly perpendicular to lead number 1.
So 90?
Yes, that's 90. Perpendicular to lead number 1, 90 plus 90 or minus 90, but AVF is positive, so that means that's a plus 90 degrees. Okay, that's good. All right, so it's 90.
And it looks like it's like sinus rhythm because we can see the P wave before every like QRS. So it's a normal sinus rhythm.
Okay, very good, very good, very good. Thank you. All right, now let's see 103. Who has 103?
I do.
Okay.
Okay.
Do you want to share your screen or let's stick to mine?
I think we can stick to yours. It's okay.
Good.
Okay, so starting with rhythmicity. So I found that it's quite rhythmic. And then regarding the heart rate, I got 140.
That's okay.
Which was like barely in the normal range, I think.
Well, it's not in a normal range because the normal range is, we said 60 to 100. So this is over 100.
Tachycardia.
So it's tachycardia. Okay. So that means tachycardia. All right. Axis.
Okay. And then axis, so lead 1 is positive. And then if we look at AVF, AVF is also positive. So it would be plus 90 degrees.
It's normal. It's normal. It's
yeah.
between 0 and 90 degrees. None of them is equiphasic. Okay. This is the, let's say, the axis that we solve together. The lead number 3 is the smallest one. So if I come here, it's almost equiphasic to 30 or 210, but because lead number 3 is a little bit positive, more positive, this is why you have to get a little bit closer to lead number 3. This is why we said 40 or 50. Similarly, what we said, 1, 2, 3, which is the biggest for lead number 2, after lead number 3 and lead number 2, lead number 1 and lead number 3. So this is why not here, but a little bit closer to lead number 1 because lead number 1 bigger than lead number 3. So you're getting closer, about 50 or 40, the same as you decided by using this equiphasic lead. Okay. Do we have P waves?
You mean the impulse abnormality?
Yes, no, impulse formation. Yes, that's all. Okay, so yes, we do have P waves. See, we do have P waves, and in AVR is negative, so that's a sinus tachycardia. Okay, sinus tachycardia. That's an abnormality. It's not a normal sinus rhythm, but that's a tachycardia, sinus tachycardia. Okay.
Okay.
Good. 104. Who has 104?
I'll do it.
Okay.
So the rhythmicity, I would say it's rhythmic.
Well, and I don't think so, because if you look
Okay.
at the distance is longer, shorter, 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 and starting be longer again. So that's changing, a little bit changing, okay? And looks like it's a the bradycardia, and after a little bit speeding up, slowing down, splitting. Okay, so it's not
irregular.
Irregular, it's okay. It's irregular, but if you look at a longer strip, but we don't have a longer strip, that can be a regular irregular because it's repeatedly doing the same. We will get to this point, don't worry. But let's first look at the heart rate. Now, what could be the heart rate?
So using the rule of 300, I counted about.
It's not good, not good because it's not rhythmic. If you do have rhythmicity by divided 300, it's okay. But if you have this kind of arrhythmia, you should count a longer interval. For example, 1, 2, 3, 4, 5, 5 seconds, 1, 2, 3, 4, 5, 6. 6 times 12 means 72. So that's normal. Okay. Did you follow me? So if you have a, let's see, average, calculating the average rate, you have to count a longer interval. And after you have to multiply to 60 seconds, okay? So that's normal, 75, okay? Axis?
So for the axis, I use the equiphasic approach for lead one.
Yes.
Lead one has the most equiphasic QRS complex. So I need a perpendicular to that is the AVF, and AVF has a positive QRS, which means that the axis would be positive 90 degrees.
Good, very good. Okay. Now, next one, impulse formation. We do have P waves, and the rhythmicity of the P is the same as a QRS complex, okay? However, it's sometimes is slower one, it's fasting up, slowing down, fasting up, and looks like the rate of this one, it's around about 20 per minute or so. So very similar to the respiration rate. Now, so what kind of rhythm we have? This is what is called
respiration.
Sinus arrhythmia, sinus arrhythmia or respiratory arrhythmia. This is what we can say it. Okay, clear? So this is still a sinus impulse formation abnormality, and that's a rhythmic, so that's a sinus arrhythmia. Okay, good. 105, who had 105? Nobody. Who wants to do it?
Oh, the person who has 105, I don't think his mic is working, but he wrote in the chat. So if you check your chat, maybe.
Okay, that's it. Yeah, okay, so somehow doesn't work the microphone. Okay, so Uncle Lee, okay. All right, so he said this is arrhythmic. Okay, microphone is not working. That's great. Okay, so heart rate is 91. That's okay, about normal. Equiphasic lead is lead number 2. That's very good. So, okay, AVF is negative. So the axis is, it's not good. It's meaning one is positive, AVF is negative. So
it should be like minus 90 to 180.
Okay, let's go step by step. Okay, what we see here. Okay, so first of all, we said that lead number 1 is positive. Okay, and he said if lead number 2 is equiphasic. Okay, let's go for the equiphasic approach, what he written here. Okay, so the equiphasic approach, what we had here, showing that lead number 2 is equiphasic. What does it mean? Lead number 2 is equiphasic to minus 30 and 150. Okay, this is a 2 equiphasic portion to Lead number 2. All right. Now, look at AVF. You said AVF is negative, so we are here. It's meaning that the axis is minus 30. Okay, that means minus and 30. However, if you go back, lead number 2, a little bit positive. Okay, a little bit positive. It's not exactly equiphasic, a little bit positive. So this is why we could say that this is not exactly minus 30, but a little bit less than minus 30. You can say that maybe minus 20. So that's a left deviation. All right.
I have a question.
Yes.
So when you determine whether leads are equiphasic, is there like a specific criterion by which you say this is equiphasic and this is not? Because just now you said leads 2 is a bit positive, but is that based on just like experience or?
No. Look at the millimeters.
So here, we count.
Yes, you count. Okay, count.
Right.
How many you have up? 1, 2, 3, 4.5. Okay, 5, because it's a little bit down. So 5 up, and 1, 2, 3, 4, and 4 down. So we still have 1 millimeters up positivity. So this is why I said that's a little bit tiny more positive. So this is why it's not exactly minus 30, but a little bit less than minus 30. This is what I showed here. So this is why you are coming back, because this is located on this side, not on that side.
Okay.
Okay. Now another thing. Okay. What is the impulse formation center? Oh, let's see. I'm waiting the chat. So the axis is near to minus 30. Yes. Yes. But let's see the impulse. Do we have P wave? Yeah, we do have P waves. However, this is not rhythmic. You can see that, for example, this bit or this bit comes earlier, and that bit doesn't like as that. Now let's see. We do have P waves, okay? We do have P waves in front of almost every QRS complexes, but if you are looking at this bit, for example, or compared to this one, look at, they are not the same, see? If you go down and look at in the all leads, you can say that this P is located in front of the QRS, but is not identical to the sinus P waves. So it's meaning that this coming earlier, so that's a premature bit. And because we do have a P in front of it, we can say that's an atrial premature bit because it did not come from the sinus. This is a sinus bit. Now, again, this is not a sinus, as you see here. Again, that's not the same. And I would say that this is not a sinus P wave either, because the morphology is different. So we do have sinus written interrupted by atrial premature beats, and is not coming from the same focus, the same area of the atrium, because we do have two different morphology of the P wave. So that's, we can say, that's a multifocal atrial premature beat formation we have.
I have a question.
Yes.
Can we also call it a wandering atrial pacemaker, since it's more than two morphologies?
No, you don't need to have pacemaker.
No, wandering atrial pacemaker.
No, the pacemaker be different. When the pacemaker has a spike, and this is not a spike. So when the pacemaker is firing, it gives you a little spike. And if you pace the pacemaker in the atrium, it still can be, but you do have a little spikes at the beginning of the P wave.
Okay.
Okay.
Can you calculate heart rate as well?
I think I already did, but we can calculate it. Yes. Okay. Let's see. Let's calculate the heart rate. Because it's a rhythmic one, we have to see the average. This is 1, 2, 3, 4, 5. 1 second, 2 second, 3 second, 4 second. We do have 4 seconds. And how many beats we have? 1, 2, 3, 4, 5, 6. 6 times 15 means 90. because you count it for 4 seconds. So this is why you have to multiply by 15 to get the results till 60 seconds.
Excuse me?
Yes?
I don't understand this method that you use for irregular rhythm.
The heart rate. Okay,
Yeah,
so you don't. Okay, all right. How do you count the pulse? What you do when you want to see the pulse rate of a patient, you are holding the pulse and counting a bit for a certain time period. You can count till 15 seconds, or you can count till 30 seconds, or you can count till 1 minute. If you count till 1 minute, you will get exactly immediately back the pulse rate in 1 minute. If you counted the rate only for 30 seconds, or means half minute, you have to multiply by 2. If you counted the pulse for 15 seconds, you have to multiply by 4. This is very, very similar, except we don't have 15 seconds, but if you had 6 seconds, it's okay, because you have to multiply by 10. So if you count only for 6 seconds, you can multiply by 10. If you count only for 5 seconds, you have to multiply by 12, because you want to see how many beats you have within 60 seconds. Okay?
Okay, thank you.
All right, let's go on.
Professor?
Yes?
So you would call that multifocal atrial premature beats, correct?
Yes, as you can see, this is a multifocal atrial premature beats. Okay, yes. All right, 106. Who had 106?
I think it's mine.
Okay.
But I'm not sure. I feel like it's not the same on the thing you sent on the link.
It's all right.
Yeah, but I can just do it now, I think.
What did you? I think it's 106 should be the same.
Well,
But
it's
okay.
like, it's not like the kind of paper is not like that. It's more like gray.
Oh, okay.
I don't know if I got it wrong, but
possible.
anyway, okay.
I can check it. I can check it. Immediately you will see it, and after you can say it. Okay. All right. Maybe I did have different one for the first one, because that tracings at the first, maybe let's look at this one. 106, the same. Okay. Let's see another one, maybe the first one. And the same, not the same.
Well, I don't know.
Yeah, the same.
But yeah, but I can just do it now, I think.
This is about the same. Okay, let's see.
So I think it's not rhythmic.
Good.
And what's next that I should do?
Next on the heart rate or axis, doesn't matter. Heart rate or axis.
Lead 3 is like equiphasic.
Equiphasic. Okay.
So if I find the one perpendicular to it, that would be the AVR.
Why? Yes, one is AVR because 210,
Yeah,
and another one is
210. The other one is 60. No, 30.
100. Yes, exactly. 120 minus 90 is 30. So this is 30 or AVR. No.
But AVR is negative, so
Okay,
it's the other. So it's 30.
Yes, it's close to 30. Okay, but again, you can go for, it's more the negative, this lead number 3, if you do see, because one is bigger than lead number 2. So you are not located exactly in the middle of lead number 1 and lead number 2, because in that case, 1 and 2 should be same. However, you are located a little bit closer to lead number 1. Okay, that's only, maybe it's 20 only. Okay, go on.
And the heart rate.
Okay, heart rate. Again, we can come here because you do see it's 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. How many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 5 seconds, you have to multiply by 12.
144.
Yes, it's tachycardic for sure. Okay, good. Next one, the impulse formation. Do we see nice P waves?
No.
No, but we do see P waves. See, we do see P waves, but these P's are different one. And they are coming randomly. So we have arrhythmia absoluta with different P waves. So that can be a multifocal atrial tachycardia because it's tachycardic.
Yes.
Okay. So if we do have different P's as we had before, that we only had one beat, not written, we could say that that's a multifocal atrial premature beats. But because we have rhythmicity and complete, this is a rhythm, we say that's a multifocal atrial rhythm. But because this tachycardic one, you can say that the multifocal atrial tachycardia. Okay? For everybody? Okay, let's look at 107.
Yeah,
Who wants to have 107?
That's me.
Okay, momento.
So it's irregular. It looks like atrial fibrillation. The axis, let's say 1 and AVF are quite positive, and lead number 2 is the biggest one,
Okay.
so close to 60.
Okay.
And that's it.
All right, but what is the impulse formation center here?
Atrial fibrillation.
Exactly, that's an atrial fibrillation. So the arrhythmia, no P wave, atrial fibrillation. Very nice, very good. Okay.
And the rate is 84.
Okay, good, very good. Congratulations. All right, 108. Who
It's
has?
me.
Okay, your turn.
Okay, so for me, this looks like irregular.
And
so
well,
for her,
okay, it's irregular, but not exactly, not totally irregular. Okay.
Yeah. So well, I thought this irregular. Sorry.
Doggy, yeah.
Yeah.
Wants to say it as well.
Calm down, baby. Okay, so I count the number of all waves for the 6 seconds.
Okay.
And there are 8 all waves, so I multiplied by 10, and so heart rate is 80 BPM.
Yes, it's about 80 BPM. Yes, it's fine.
And for the axis, so the lead one is positive, and also AVF is also positive. So this is normal axis.
Okay.
0 to 90.
Okay, and if you look at, let's see, lead number 2 is the biggest one, so it's around 60. But lead number 3 is bigger than lead number 1. So this means it's over 60, so it can be around 70. Okay, all right, go on. Let's see the impulse formation.
Well, there is P waves, so,
Yeah.
so this is normal.
So we do have, as you see here, we do have P waves, but here the P is different one. And that bit a little bit earlier.
So the premature.
But what is the location of these premature beats? So what do you think?
Quadrant thing.
Well, which one? Exactly the opposite of the P wave. So it looks like, okay, so that's the heart is placed here, okay, and normally the P is that one, that AVR is negative, lead number 2 is positive, but looks like now that atrium is activated backward, okay, so that can come from the AV junction. So that's a junctional premature beat. Okay, and because every 1, 2, 3, 4, 1, 2, 3, 4, every 4 bit is a junctional premature bit, this is called, yes, this is called, what? Quadrigemini, exactly, junctional quadrigemini. This is what it has, okay? So that's a junctional quadrigemini. Okay, good, all right. Interesting. Okay, let's see this.
Yes, this is mine.
Okay.
First of all, we can see it's arrhythmic.
Okay.
And the heart rate is 70 beats per minute. I didn't calculate with the 300. I did the method of
average
counting for 6 seconds and then multiply by 10.
Okay.
And I have used the quadrant approach, and I got that the axes are exactly -30.
Okay.
And this is also atrial fibrillation because we don't have any P waves. And we can see a little bit of F waves in the number.
Yeah, but if you don't see, that's still fine. So that's an atrial fibrillation, the normal rate, and we do have an axis is -30. Correct. Congratulations. Okay, let's see 110, this one.
Okay, that's me.
Okay.
Okay, so the heart, okay, first it's rhythmic, and then secondly, the heart rate is 28.6 beats per minute, or rounded up 29.
Okay, that's good.
And then the first lead is equiphasic. So it's the QRS axis is 90.
Okay.
Plus 90.
Okay,
degrees.
good. Good.
And okay, so there's a premature atrial contraction.
I don't think so, because that's rhythmic. If you want to say premature beat, it should be arrhythmic. When you place the premature beat, that should come earlier. Okay, but this is not, it comes in time. So?
I don't know.
Yes, you know. We do have P's, however, we do have much more P's than QRS complexes. And when you said that the rate is very slow, it's much closer to, let's say, 30 or less than 30. So this could mean that this is not a junctional, that's possible as a ventricle rhythm, okay? And this PPPP independent from the QRS complex. So you can say that this is a third-degree AV block, but we haven't dealt with this third-degree AV block, okay? So this is, you can say that the junctional escape rhythm or ventricle escape rhythm, okay? This is what you can say. It's not exactly ventricle, because if you had a ventricle one, that QRS should be wider and the T should be negative, but here is a positive. So that possibly is originated from the lower part of the junction. And this is why we died. But for sure, that's an escape rhythm, what we have. Okay.
Okay, thank you.
All right. Okay. Let's see this.
It's for me, and I think it is rhythmic and heart rate.
Well, except here.
Oh yeah.
Okay.
So
good.
It's arrhythmia.
All right.
And the heart rate is I think it is arrhythmia, so I need to calculate again.
Yeah, but you can use this 300 because it's mostly rhythmic in one pace, a little bit faster, but possible that's a compensated one, so the heart rate doesn't change too much. And if you count how many big square we have between the R's, 1, 2, 3, 4, 5, a little bit. So that's bradycardic. So it's around 45 or so. Yeah, or 50. I'm seeing for 50. Okay.
Okay. And the further axis, the red one is the positive, and then AVF is negative.
Okay.
So when we see the lead 2, it is also negative.
Okay. So
and then if we see the lead AVR is negative, so it's -30 to -60.
Exactly. So that's around exactly. Very good. Very good. So that's an extreme left deviation or pathological left deviation. So we will learn later on that can be due to anterior hemiblock that we do have. And that's a sinus written. And this bit, what do you think? What kind of bit is this one here? The QRS looks like the same. We do see, well, I don't see any kind of P wave or front of it, but for sure that's QRS is narrow. So it can be atrial or junctional premature bit because it comes earlier. So that's a premature bit. Okay.
Okay, so is it junctional premature?
Possible it's a junctional one because we don't see any peak. Peak can be located inside the QRS complex, or it can be atrial one, but somehow displaced in the where the P wave is located. So, well, look at here. For example, lead number 3, if you look at this is a normal situation when we do have a T wave, okay? And here, a little bit different one. So here we do have a bump up. So that can be an atrial one. I would say that's an atrial premature bit.
Okay.
Okay, so due to the little abnormality in the tail of the T wave here, and that's a positive, so possible that's a atrial premature bit. Yes, okay, good. All right, 112. Anybody has?
Yes, this is mine.
Okay.
So first, I think it's a rhythmic, and then the heart rate. So I see 3 big squares, so around 100, maybe a little bit more BPM.
Okay.
For the axis, okay, I think, okay, one is equiphasic.
Well, it's negative. I would say that
Negative,
one
oh.
is negative, okay?
Okay. So if I want to choose equiphasic one, so I should choose the AVR.
Okay.
Okay, so the AVRs and the perpendicular to this one will be lead number 3, which is positive. So I would say the axis is around plus 120.
Okay, yeah, or a little bit less because AVR is negative, so that's around, well, 110 or so, we don't know. You can say that's an extreme right deviation, so you don't need to think too much about it, okay?
Okay.
And you do see sinus, impulse formation, and the rate, everything is normal, so that's it. Okay, so there's normal sinus rhythm. Okay, good. All right, let's see this one. 113, okay.
So it's irregular, the rhythm, and the heart rate is about 60, I think, in 5 to about 5, so it's almost not about normal. And the lead 1 is positive and AVF is negative, so it's left axis deviation, and then lead 2 is slightly negative, maybe.
Okay, yes, you can say it, yes.
AVR is negative, so the axis would be between -30 and -60.
Very good. So that's an extreme left deviation. All right. Okay.
And
now, yes. What caused the arrhythmia?
I think it's premature atrial beat.
Yes. So for example, here, okay, that's here and here. So these are atrial premature bits, and looks like this from the same area. So the monofocal atrial premature bits. That's it. Okay. All right. Okay. Let's see this. Well, it's bizarre, but anybody has this 14?
Yes, I have it.
Good.
So the heart rate, I said, so first I said it was rhythmic. And so I used the 300 method and I said it's about 100 beats per minute. So that's borderline, but normal. And then I said there was a right deviation because I used the quadrant approach.
Very good. One is negative, AVI positive for sure, and AVR is positive. It looks like mostly positive, so that's an extreme right deviation.
You'd call it extreme, okay. Okay, extreme.
Or pathological, doesn't matter. But it has, let's say, that's not normal, so you cannot explain based on the anatomical situation. This is what we wanted to say, okay? All right. Yes?
No, I don't know what happened here.
Okay, so, but does it mean, so far it's negative, right? Do we have P waves?
Yes.
Lead number 2 positive, AVR is negative, so that's a sinus rhythm. Okay, there's no problem with that one. Later on, we will learn that when we do have an extreme right deviation, that can be the posterior hemi block of the left branches. Okay, good. That's it.
I have a question.
Mm-hmm.
Can you say whether the S1 Q3 T3 for
there is no Q wave here. That's a pulmonary embolization that we will see it later on, don't worry. But here I cannot see a Q wave in lead number 3. That's not pathological Q wave in lead number 3. If you do have, S1 is all right because we do have a right bundle branch block. That's okay. But
and
we don't
also
have Q wave. Yes, we don't have a Q wave in lead number 3. This is why I don't think that's anything. But it has an additional problem because you do see a very, very, very deep ST depression. So, but later on, don't fly. Let's first walk. Okay. Anybody has this one?
Yeah.
Okay.
So it's a rhythmic one.
Mm-hmm.
And also like a sinus.
Mm-hmm.
And lead one is more negative and AVF is positive. So we are in the right deviation.
Okay.
And it's like around 75 BPM, so it's like normal.
Mm-hmm. Okay, and sinus rhythm. So that's okay, we can say sinus. 16, anybody has this 16? Or no?
Yeah,
Passive.
No, you gave us only until 15.
Okay,
Yeah,
15.
give us only until.
Oh yeah, because later on I send you this one. Okay, let's see. Come on.
Okay, so lead, I think it's rhythmic.
Okay.
Yes. And lead one is positive.
Mm-hmm.
And AVR is negative.
Mm-hmm.
So it's gonna be negative 30 or closer to negative 30.
Mm-hmm.
And also we see P waves. Yes.
Mm-hmm.
And the heart rate is around like 100 beats around that area, 100 beats
100 beats per minute, yes, you can say.
Yeah.
Okay.
And yeah, since it's really
okay, axis, have you figured out the axis? I've lost.
The axis is gonna be this is gonna be negative 30. It's gonna be
no. 1 positive, AVF positive, but this is the ST elevation. Later on we will see it. And lead number 3 is about equiphasic, so it's around 30. So that's
30,
around
yeah.
30. That's around 30. Okay, good. All right, now let's jump to the next one. Oops, okay, no problem. I'm going to project the next slide. Next slide. Yep, tracing. Okay, impulse formation abnormality, and I'm sharing it. Okay, and good. Okay, you can see it. 101. Who has 101? Nobody has.
They're probably not here.
Okay, go on. 102. Well, let's do this one because now it's a nicer one. And who wants to have this ECG? Anybody can do it. Let's go for it. Doesn't matter how it looks like. You will learn.
I can try, but I need your
Try
help.
it. Try it. It's okay. I'm here to help you. Don't worry.
Okay, so first, if it's rhythmic or arrhythmic, so it looks like arrhythmic. And then regarding the heart rate.
Okay, all right. Let's see the heart rate. Again, we have to count. Let's see. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3 seconds. 1, 2, 3, 4, 5. 4 seconds. 1, 2, 3, 4, 5. 5 seconds. 1, 2, 3, 4, 5. 6 seconds. How many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 120.
Okay, so yeah, tachycardia.
Okay.
And regarding the axis, okay, so.
All right, very good, very good. Now, which one that you will consider?
Okay, I'm looking first at lead 1 and AVF, both.
Yes, but the
positive.
normal one. Okay, let's consider the normal bits. Don't consider these bits.
Oh.
Okay, so only look at these leads and you can see that lead number 1 and AVF is positive, so that's normal.
Normal, yeah.
Okay, good.
Now the impulse generation.
Uh-huh.
Okay, so I'm looking for a P wave. And I don't really see a P wave.
Well, it's rhythmic. It's rhythmic. Yes, it's for sure. This is one possibility. And in this case, you can go for V1, for example, or any other lead.
Oh.
I would say that that's a sinus rhythm, but we don't see very nicely the P wave, but it's rhythmic. And in the rate of the sinus that we have. Okay, so I would say that it's a sinus rhythm, but the sinus rhythm is interrupted by
This is what a wide QRS.
And see why the QRS and the T is negative, inverted, meaning that impulse.
It's a ventricle, something in the ventricle.
Yes, it's a ventricle premature beat. That's it.
Okay, yeah.
Ventricle premature beat. And when you compare the ventricle premature beat, and they look the same. So within one lead, they look the same. So I would say that it's originated only for one focus, so it's a monofocal ventricle premature beat. Very good. Okay, very good. 103. Who has 103?
I'm supposed to have 103, but
I'm supposed to have it. What
well,
does it mean?
yeah, I thought this was for next class.
No,
so
that was okay.
Looked at it, but I can try.
Try.
Okay, so first regarding the rhythmicity, I think this is quite rhythmic. And then the heart rate, well, we have, because it's rhythmic, we can count the number of big squares and then divide 300 by it. So it seems like almost, I don't know, like 2.7.
Okay,
maybe.
so it's less than 3. That's enough.
Less than
okay.
3, yeah.
So
it would be 300 divided by 2. It would be around like 110.
Yes, 110 means
within the normal.
No,
It's a little bit tachycardic.
There is no little bit.
Okay, it is
Tachycardic. Okay,
tachycardic.
As somebody is approaching you, a very nice guy. First of all, he's saying that I like you a little bit. No, I don't think that he's coming next time.
Okay, so it is tachycardic.
Okay.
Okay, and then when we look at the axis, so lead 1 is definitely positive, and AVF is also positive, so it's normal. And then regarding the impulse abnormality, so we do see P waves in front of every QRS. and they do seem quite the same, I think. So it's, and then the P waves are also rhythmic. So we have normal sinus rhythm.
Okay, but not normal because the rate was faster than 100.
Yes,
so that's
okay,
a
so
sinus tachycardia. Yes,
okay.
that's it. Good. Okay. Yes. Who has 104?
I do.
Good.
So first, I think it's rhythmic.
Okay.
And because it's rhythmic, for the heart rate, there's about like one point, a little bit block between the two.
Yeah, 1.5.
intervals.
Okay, 1.5.
1.5. So it should be around 300 beats per minute.
If you had two squares between R, 150. If you have one, that's 300. So between 150 and 300, you can say 200, for example, or 210. Doesn't matter. So that's for sure is tachycardic. Okay, go on.
Yeah, and the main dialectical axis. I use the equiphasic approach for this. I thought that lead number 2 has equiphasic. So yeah, so 90 degree, that perpendicular would be AVL. And AVL has a positive QRS. So the axis would be 150 degrees positive.
Why? AVL is positive. You are on the left side. AVL is minus 30. Okay. Look.
So
that is 150. But you are here because AVL is positive. Yes?
Yes.
Okay. Go on. Okay, go on.
So it'd be 60.
Well, you said minus 30. Okay, you said one is positive. Okay, one is positive. Lead number 2 is equiphasic. Okay, one is positive. It's meaning that you are on the left side. Yes, you are here somewhere. Okay.
Yes.
Lead number 2 is equiphasic, so you are here. Okay.
Yes.
But similarly, lead number 1 is positive, AVF is negative. And this is, yes, AVF is negative or close to negative. Okay, so that's minus 30. That's okay. You had 150 if you had negativity in AVL, but in that case, lead number 1 should be negative as well. But you are on the left side. Okay, go on.
Okay.
Impulse formation.
I wasn't really sure about this, the impulse formation.
Yes, you can be sure. Okay, first of all, that's rhythmic. Do you see P waves?
I think so.
I think so. Okay, but if you do have P waves, okay, I don't see any P waves, but if you do see P waves, I'm very happy that you do see P waves. Okay, let's think a little bit. If you want to say that that's a sinus tachycardia, that's wrong. Why? Why it cannot be sinus tachycardia? It's impossible that this ECG is a sinus tachycardia.
I don't know.
Yes, you know, but you cannot recall what you already know. Okay, what can be the maximum rate of the sinus? Because the sinus rate is limited. It cannot fire at the rate of 300 per minute. It has a maximum, and the maximum depending on the age. You learn it in physiology. And what you learn, 210 minus the age. That's the maximum rate of the sinus. If you want to exercise and you want to do some aerobic training, you know that you have to have for a certain period of time to have about 80% of the maximum heart rate or so. Yes? Anybody is doing some exercise? So it's meaning that if somebody has a rate of 210 and the age may be 50 or 60, for sure it cannot be a sinus tachycardia. However, this QRS is narrow, and if you do see some P waves, you can say that that's an atrial tachycardia. It can be a paroxysmal atrial tachycardia. But to say that that's a paroxysmal tachycardia, you have to see the beginning or the end of the tachycardia. And it should not last longer than 30 seconds. We were not there, but mostly that's a paroxysmal tachycardia that we have. But if you don't see any kind of P wave, but only you do see that the QRS is narrow, showing that it's originated from a supraventricular areas, you can say that that's a supraventricular tachycardia or paroxysmal supraventricular tachycardia. Okay? Capish? Almost.
Almost, yes.
Almost. Now, but you did understand that the sinus is not firing for any kind of rate, yes?
Mm-hmm.
Okay, so this is why the sinus, the maximum of the sinus, for example, in your age is around 180, 190. So there's no way that you can have a, let's say, the higher sinus tachycardia. If you do have a tachycardia that about 250, for sure it's not a sinus tachycardia. After, you can look at the morphology of the QRS complex. And if the QRS complex is narrow, it's meaning that the impulse is formed in the supraventricular area because the ventricle is activated through the normal conducting system. And there's no way that you can reach the ventricle muscle differently from the AV junction and the bundle of His, yes? So this is why the QRS is narrow. And as you see here, the T is positive, so the repolarization is still normal, but it's too fast. And this is why you can say that that's a paroxysmal supraventricular tachycardia. If you had a P wave and you say that, I do see a P front of the QRSs, you can say that paroxysmal atrial tachycardia.
Okay.
Later on, you will understand. Yes.
Can we call it junctional
Yes,
tachycardia?
you can say it. If you don't see any kind of P wave, you can see the junctional tachycardia because it's meaning that the P is located inside the QRS complex. And most commonly, about the majority of the paroxysmal tachycardias, supraventricular tachycardias originated from the junction, so you can say it.
Oh, okay. So junctional tachycardia is a specific type of supraventricular tachycardia.
Correct.
Okay.
And atrial tachycardia is a type of a supraventricular tachycardia, and junctional one is a type of, yes.
So if I want to be on the safe side, I can just say supraventricular.
Exactly. You are not saying big mistake if you say supraventricular. Yes, nothing.
Okay.
You're still in business. And if after they show you that, hey, I do see some P wave, look at here or there. Okay, that's an atrial tachycardia, fine. Unless you do see a negative P in front or the behind of the QRS complex in lead number 2, because that's a junctional tachycardia as well. Okay, let's see this one, 105. Who has 105? Nobody. $106?
106 is mine.
160. Yeah, you can do both.
Well, but I didn't do mine either, so. Oh, I didn't know how to do that exactly.
Okay, now let's see it. 105. Let's start with this one. Rhythmic or not?
Yes.
Okay, good. Heart rate?
All right.
Because it's rhythmic, you can count how many squares you have. 1, 2, 3, 4, 4.5. So it means around 80?
Normal, yeah.
Okay.
And the next one is the axis.
Okay, axis.
Number one, lead one is positive. And the AVR is negative. So it's like
one is
normal.
positive, AVF is negative, for sure is not normal. And lead number 2 is negative, so the axis is?
Right.
Why right? One is positive, it cannot be right.
Oh, yeah.
It has to be left, this extreme left deviation. It's meaning again that 1 is positive on the left side, 2 is negative, so you are somewhere here. You can look at AVR. If AVR is positive, you are here. If AVR is negative, you are there. And AVR is negative, so you are here.
So that is the left deviation?
No, that's an extreme left deviation because it's over -30, between -30 and -60.
Okay.
Okay, now what about the impulse formation?
The impulse.
Yeah, what generates the impulse? Is this a sinus rhythm? Do we see very nice P wave in front of every?
I think there is P wave, but it's not.
Yeah, what kind of wave is this one? This looks like as a. Hopefully somebody will know it.
F wave?
It's like flutter.
Yes, flutter wave, sow wave. Exactly, looks like as a sow. See, these are the teeth of the sow. Okay, so that's an atrial flutter with a 4-to-1 conduction. Very good. And yours 106, the same, except the conduction rate is varies. Because here about 4-to-1, this is why it's rhythmic. In 106 is different one, so this is why it's arrhythmic. Okay.
Well, at the beginning, it's like rhythmic, and then it starts to be.
Yeah, but doesn't matter. It looks like it's 3-to-1 or 2-to-1, and after you have 4-to-1, again back to 2-to-1, 3-to-1. So it's a variable of the conduction rate. Okay, this is about the same. Okay, I don't want to spend too much time. That's again the sow waves. If you do see this kind of sow waves, but the rate the conduction is much slower, so there's a much higher degree the block that we do have in the AV junction. Let's look at this one, 108. Who has 108?
Well, it's mine, but
Good.
I'm kind of lost here. Okay, so anyway, so
looks like the second part of the lesson. Nobody watched it or nobody understood it. It's okay, because for the next time we will have the same as the impulse formation, but we add additional on the conduction abnormality. So it's no problem, but we will keep up, or we will catch up with all things. Okay, let's see. Is this rhythmic or not?
So this is not rhythmic.
Okay, not at all.
Rate. So I counted 6 seconds.
Counted.
And there are 16 O waves for 6.
Okay, so
6 seconds. So it's 160.
Very good. 160. Okay, go on.
And for the axis, the lead one is positive, and also AVF is also positive. So this is in the normal range.
Okay.
From 0 to 90.
Looks like AVL is equiphasic, if I say yes.
Okay.
So AVF is equiphasic to lead number 2, for example, this one side, and it's positive, so it's okay. It can be around 60. It's fine. Okay. Go on. Impulse formation center. Do we see P waves? Nice sinus P waves.
No.
No. Do we see P waves?
I would say no.
Okay. So arrhythmia absoluta, no P wave. Immediately you have to say it. That's a atrial fibrillation, okay? So you don't need to see the fibrillatory waves. Here you do see some fibrillatory waves, okay? For example, here, but you don't need to see it. It's enough if you say that's arrhythmia without P waves, okay? It's enough.
Can I ask regarding 106? We said it's a atrial flutter.
Which one? This is not atrial fibrillation.
106.
106, yes, that's a flutter. See, can you see the sound waves? Yes, but it's arrhythmic. A flutter can be rhythmic or arrhythmic. Fibrillation always arrhythmic.
Oh, but if both are arrhythmic, how can I differentiate between?
Very similarly, because when you do have a flutter, you do have flutter waves. Okay, you do have flutter waves. And if you see the rate of this atrial contraction, this is less than 300, as you see here. See?
Oh.
Why in a fibrillatory waves, it's more than 350. So if you do see some P waves and the rate of this kind of wave, it looks like flutter waves or any kind of waves, you say that's we faster than 350, you could say that's a fibrillation. Okay. So the first of all, the matter of the wave types that you have plus the rate, it's important. If you watch the video, you will see it. Okay, good. So that's an atrial fibrillation. Very good. Let's go on. 109.
Excuse me, can I ask a question about 108?
Yes.
So, but in atrial fibrillation, QRS usually normal, but is it normal?
Well, yes, it's a normal, but we do some abnormality, different abnormality. That patient has an ST elevation, myocardial infarction, or STEMI. So that's different one. This is not only that we are stating that that's a normal atrial fibrillation without having anything. Yes, we do have some other abnormality on this tracing as well. But we haven't studied yet.
Okay.
109.
Yes, I think it's the same one from the previous file. So
except
we discussed it already, but it's atrial fibrillation.
But the QRS complex is much nicer than in the previous one. Yes. And as you see here, the axis, what about the axis?
The axes are exactly -30. It's a left deviation.
Okay, that's a left deviation, exactly. And the rate is around, well, you can say this is normal, around 60s or so. Okay, good.
Yes.
Okay. 110?
Me. Okay, so it's non-rhythmic and the heart rate is 140 beats per minute.
Okay.
And then so the first lead is equiphasic. So the electric axis or QRS axis is 90 degrees positive.
Okay, good.
And what else?
Impulse formation center.
Yeah, okay. So we can see the P waves are and the second lead, the P waves have different shapes.
Well, I won't say, okay, it's different one, but if you look at the rate of this called P wave, as you wanted to say, look, it's more than 350. See, can you see it?
Yeah.
So this is why, because the rate is more than 350, so it's very, very tachycardic in the atrium. This is why the diagnosis should be?
Second. Okay.
Atrial
fibrillation.
Exactly, atrial fibrillation. That's supposed by, let's say, supported by the arrhythmia plus the very high rate of the atrium that originates in the atrium. Okay, so this is the answer. What somebody asked me about the flutter and fibrillation. How can we this? You can use the rate as well. So the atrial rate can be used. If it's less than 300, that can be flutter. But in that case, for sure, the atrial, the morphology of the atrial contraction will give you a bigger sign, not this small one. Okay. So it's not yes, who has this one? Now that's a tricky ECG.
It's for me.
Okay, that's very tricky one, and I hope you figure out. No,
yeah,
I don't think so.
No, yeah, I'm not sure, but it's rhythmic, and so heart rate is 60, and there is not P wave. Okay, for the axis, the one is the positive, and AVF is also positive, so it is normal. But I'm not sure about, so I think it's junctional escape rhythm.
Very good, very good. That's a junctional escape rhythm. However, look at this. Looks like you have fibrillatory waves.
So is it also atrial fibrillation?
Yes, but how can you have atrial fibrillation with having a normal rhythm? Because this patient has a third-degree AV block. So there is none of the impulse from the atrium goes to the ventricle. However, the junction is still forming an escape rhythm.
So it has both?
Yes.
So did you say third atrial block?
Not atrial, AV junctional block. That's be the next seminar that we are going to discuss on the next week.
Okay.
So I am sending you those videos as well that you have to watch. And of course, you will receive some additional tracing that you have to solve. And don't forget, not only in the future, whatever we are studying, right, but you have to know whatever we already did. So for sure, the impulse formation always coming back, or the conduction abnormality always comes back. So we have to know it. And finally, we will figure out everything on the tracings, because this tracing has multiple problems, such as this one. For example, we have a conduction abnormalities, and we do have an impulse formation abnormalities as well. Okay.
So the third AV junctional block is the combination junctional escape rhythm and atrial fibrillation?
No. Third-degree AV block means there is no connection between the atrium and the ventricle. But the patient life can be, or the patient can survive if we do have some kind of escape rhythm that is originated from below of the block. For mostly, it's coming from the ventricle, but in the ventricle one, it should be wider and inverted, and so it's not a ventricle and much slower. This is a junction, and depending on which part of the junction is affected, if it's a proximal one, you can have still some nodal tissue that can generate an escape rhythm. Okay?
Okay.
All right, guys. So that was for today, and hopefully you will keep learning what you already have to do it, or had to do it before. And I'm giving you some new tracings and new material to watch it. You can watch several times. An additional one. Somebody